Hi, everyone. Hi, everyone. Thank you, thank you. Hi. So, first of all, thank you very much for being here. It's wonderful to be standing in front of you to talk about the future of blockchains. And you probably think that I'm going to do what I usually do, which is talk about the recent successes of Avalanche, the recent developments on Avalanche, the new things we built, etc., etc. I'm not going to do that. I want to talk to you about a blue yonder idea, something that's so crazy that it's either incredibly stupid or really promising, but it's nothing in between. So I want to talk to you about what I call coin-operated agents. So, what has happened recently? Well, blockchains came of age. For the longest time, I've been in this space for a very long time, since 2002. And I was there before the white paper, I was there after the white paper looking at its strengths, and then I've been in this business for a very long time. People talked and talked and talked about scaling blockchains, how to make them faster, how to scale them horizontally. And Avalanche addressed those needs. You know all about the consensus protocol that we pioneered, you know all about subnets. I don't need to repeat this. There are many other fights to fight. There's still a lot to build. That's all true, but I think the area is now getting to the point that it's no longer in a position where it needs to dangle shiny objects in front of us. We don't need additional moon math. We are able to build and maintain incredibly demanding applications like so many of the games that are deployed and built on Avalanche. So, that's wonderful. So that's what kind of led me to look around a little bit to see what's happening. When I was a professor, I used to do this too. I would go talk to my colleagues and say, hey, what's happening in your area these days? What's happening in AI? What's happening in machine learning? What's happening in graphics, etc.? So when I look at AI, I see something incredibly promising. AI is just coming of age. They have come up with tools that are finally large enough, practical enough, and good enough for some incredibly interesting uses. And I want to talk to you about how we can integrate the two. ChatGPT, how many people have played with ChatGPT? Almost everyone. It is amazing, and yet it's just the beginning. And I want to talk to you about how we can take this amazing development from our friends in the AI space and transport it into the blockchain space. And once I tell you the idea, it's going to sound a little bit obvious, maybe, I hope. And some of the better ideas are always the ones that are supremely obvious, but I haven't heard anybody else talk about this before. So, now let's go back to our own domain and talk about the problems we face. One of the biggest problems we face is ensuring the correctness of smart contracts. They're easy to write, but incredibly hard to read and parse. It's that as a result, there have been many, many, many failures of smart contracts. I don't need to repeat to you all of the different sources of thefts, all of the sources of rug pulls, all of the sources of various different problems that we faced because there was some kind of a very deeply hidden, very subtle error in a smart contract. And why is that happening? And how can we make it better? And no, I'm not going to suggest that we can use AI to somehow translate protocols, etc. So bear with me, it's actually different than what you might imagine. So let's actually go back to the first principles and just sort of think about what's really going on when we deal with a smart contract. At the highest level, whenever we interact with a contract, there is this notion of intent. There is some idea in the back of my head that a lending platform like Aave does a certain thing. What does it do? Well, it's something like a lending platform is a smart contract into which liquidity providers pool their money, from which people take out over-collateralized debt, which is then liquidated, right? Something like that. So that's the level of my human understanding. If I had to explain it to you, I would explain it that I tried to make it fit in a single sentence, it got complicated, but that would be my human level understanding of what this thing is supposed to do. So that's that. So when I read a web page about a lending platform, that's usually what they say as well. That's how it's advertised. That's how it's marketed. There is this notion of intent. Then there is the actual smart contract. And the smart contract is actually written in a very different language. It's not at all in these human terms. Typically, it's Solidity, and typically it's very, very detailed. And it's like, well, if you do this, then you know here are the different variables, here are how the variables are accounted, here are the outcalls from the contract, here is why it's not subject to reentrancy, etc., etc. It's very, very, very detailed, very complicated, very nuanced. And it's at that level of the Solidity contract, what we call the code level, that the code is audited. Right? You need to send it to an auditor. Auditor takes your money. Some of them just rubber stamp. Some of them read it deeply. Some of them apply tools, etc. They try to check if the code matches the intent. And then, what else happens? Well, then we put this thing through a compiler, and we get the machine code. And the machine code, we almost never check. Very, very few people check the machine code. Nobody audits the machine code. We assume that the compiler tools are correct. We assume that the bytecode that they produced accurately reflects the Solidity programs that was initially inputted into the compiler. So this is sort of the setup that we have. And we were sitting around thinking about fun things to do with Avalanche, and one of the things that sort of appeared to us immediately was, well, look, this process could be so much better, and once we understand from first principles where the errors arise, then it's fairly straightforward to fix them. Where are the errors arising? They're arising from the differences between the layers. The layers breed errors. The intent doesn't match the code doesn't match the byte code doesn't actually get to do what the user wants them to do. That's typically the problem. So the DAO hack in which I played a role, we kind of looked into the program, and in our understanding of what it should do did not match what was written in the code. That's why I wrote that paper that said a call for a moratorium on the DAO. I couldn't have been any clearer about what I thought about DAO, and yet nobody stopped it. The DAO could not be stopped, and then the rest is history. It was hacked exactly as we suggested that it would. The parity wall attack. There was a mismatch between the intent and the code. And once somebody takes advantage of it, it's very hard to appeal to a higher authority. So yes, obviously nobody wanted the parity wallet to be hacked. Obviously nobody wanted that money gone. But yet it happened. And now who do you appeal to? There is no common sense. There is no one to whom you can go, this was meant to be a wallet. It was meant to not authorize funds to be moved unless the originator told it so. It never meant to lose the funds it was holding. Nobody should have suicided that contract. Right? And on and on and on. You've seen all of these, the underflow errors, etc. You've seen this at different layers in software systems. The problems stem between the lack of connection between these layers. So what can we do? So if I were a traditional academic, I would say, okay, well, here's something we can do. We can try to specify better what the intent is, and then we can use automated tools to check the code all the way down to the machine code. So I have many, many colleagues. Cornell University was incredibly strong in this particular area called program verification, also incredibly strong at automated provers of different kinds, where essentially you specify in something that's not a human language, that's a very formal language. Some of these things are things like COC and TLA+, etc. Some of you might have heard about them. How many people actually are able to write code in either COC or TLA+? There's like 1, 2, 3. I think there are maybe a few others around here, but it's incredibly few. The people who can write these are just, you think smart contract programmers are hard to find. These people are even harder to find. If you need them, there's one here, there's another one there. So they're very, very difficult beasts to find. So they're very hard to master. And even then, even if you were to master them, there would still be a gap between the intent layer and the specification layer. So instead, I want to posit to you that we could build smart contracts in a very different manner, an entirely new architecture that is obviously compatible with what we do on Avalanche because it's so low level and so flexible, but an entirely new architecture that builds on recent advances in artificial intelligence, machine learning, and large language models, and it incorporates GPTs, generative pre-trained transformers. These are the things that you played with, the thing that power the engine of ChatGPT, integrates them into the core execution engine of a blockchain. That's the idea. We call it coin-operated agents. So how does a coin-operated agent work? Well, it works kind of like this. It's a new kind of blockchain wherein the chain consists of a genesis block followed by blocks that contain free-form transaction types signed by public keys that contain arbitrary textual inputs. Okay? So this graphic is slightly off, except maybe some of it is English, or some of it is Arabic somehow. Okay, so what we want to say here is that here's what we actually want me to say. The blocks contain arbitrary blocks of text. Okay? And in these blocks of text, in a human language, you specify what you want the contract to do. And whatever you want the contract to do is executed by a large language model built into the validators. Every validator has a deterministic LLM in it, and that LLM, it actually might have more than one LLM in it, and those LLMs are identified by a version number. It's essential that we agree, before we engage in any kind of contracting, what kind of interpretation is going to be happening on the text we submit. So when the chain is started, when a subnet is initiated, we could specify the version of the LLM that will forever be interpreting the inputs. The transactions are not going to be rigid inputs like we are used to. They're not going to look like EVM transactions. They're not going to look like Bitcoin transactions or exchange transactions. They're not going to have rigid fields of input, output, etc. To the contrary, it's going to be free-form text. You will sign, literally, I give to this address 5 AVAX. Okay? And the interpretation of I give to this address 5 AVAX will be left up to the LLM. I think this is a very simple idea, and I hope the people who are getting this are getting this. So, the cool part of this, I think everybody got it now. Thank you. So, each validator keeps track of one data structure and one data structure only, which is a simple associative mapping from addressees to balances. And you can have more than one token balance, so every single address can hold more than a single kind of a token. And certain tokens can serve as the gas coin. So AVAX maybe would be the gas coin for anything we build, of course, but it could be anything else, and maybe there could be contracts that take multiple different kinds of tokens. As I said, the transactions contain free-form text. The free-form text could be in any language. It could be English, that would be great because I speak it, but it could be any other language. That's what the previous picture was supposed to show. So, for example, you can say, this transaction starts a chess game, subject to standard chess rules, where Magnus plays the white pieces, and the winner will take the pot of $1 million. You need not specify in Solidity all of the chess moves. Are you with me on this? I think this is the amazing part. The amazing part is, by context that has been built into the LLM, the common sense required for executing this contract has already been absorbed. In the same way that if I were to play chess with you, I wouldn't have to define the rules of chess with you. I can just assume that as a regular human being, you understand the rules. We now have a common basis for everything that follows. And now using an LLM, those matrices that have been built during the training period embody the knowledge that's required to execute the contract forever after. Now, you could do different things. You could say, you could write, currently, for example, this is actually kind of hard to do. If you were raising some funding for a movie, I can send you some money, no problem, on any kind of a blockchain. But now I can do, it's kind of like sending a check. But now I can do different things. On the check, I can write free-form instructions. I can say something like, I would like to send $5,000 to your funding effort, if and only if you're able to raise the totality of the $30 million required for your movie. Or in this case, you want to bring back Firefly? I'm in. I would like to send $5,000 for resurrecting Firefly, assuming you can raise the money. And if you can't raise the money, I want my money back. If you're going to do nothing with it, I don't want you using it for another purpose. I can actually write this in free-form English text and have it be executed by a smart agent built into each and every validator. And again, going back to our initial example, I can simply say, instead of writing all of that code for a lending service, I can say, this transaction creates a lending service where, liquidity providers pool their resources, et cetera, just kind of like in the first example I gave you. So now we need to think a little bit about how this works. You can't just have a free pool of floating text. It would interfere with each other. So one of the things that we need to do is provide some separation on chain between the different conversations that are happening with this agent, with the model that we've talked about. So the idea that we propose here is to introduce a notion, an abstraction called sequences. So you can have a transaction that initiates a new sequence, or you can have transactions that add to a sequence. So typically the first transaction would say, this transaction initiates a new sequence that defines a chess game, where the white pieces are exercised by this address belonging to Magnus Carlsen, and the others are, et cetera, et cetera. Or you can say, this is part of the chess game, this is move 14, here is my pay, I'm paying this much, and I would like to move e2, e4. Right? So it's kind of like a chat session, and this allows us to have separate conversations, each of which are subject to different sequence rules. So suddenly you can have one sequence of rules for whatever it is that you're providing a service for, while you provide a different set of rules for the different things that you're doing. It's kind of like enter here, ChatGPT, except on a blockchain where the chain is the smart agent executing on your behalf. Now we need to also think about fees. So without that, we're going to be exactly like all those L1s that advertise permanently low fees. If your L1 is advertising permanently low fees, there's something wrong with it, as we all know. You have to be able to push back on congestion. You have to be able to deal with load spikes. So we definitely need to have some notion of fees. And the Ethereum approach to this would not work, because you don't want to have a transaction where you execute but might abort. So you don't want to do that. Instead, what I think makes sense in this context is that each transaction carries a fee in the native gas token, and that fee is charged no matter what. So you say, here, this is my money, this is how I want to slot into the block, and execute this, and the chain consumes and burns the tokens that you threw at the agent for interpreting the text that you provided. So the key insight, let me reiterate, is that this architecture, this coin-operated agent, performs no translation to machine executable code. There are many people who are doing this. I have no shortage of people who have ideas on how to do this part. And that's not what we're suggesting. If we were suggesting that, okay, maybe that's an okay idea, then we are essentially trying to improve the current state of the art. This is very, very different. We are instead actually executing the direct language. And we can have sequences that start out in English, and somebody interacts with it in Hebrew, somebody interacts with it in Italian, in Spanish, etc. And the explorers, I'm not sure how they're going to pan out, right? They might be very hard to interpret, and we might need translators built into that for the reader. But it is exactly human language that would power this chain. No bytecode whatsoever. No translation into any machine executable thing. We will get efficiencies, but they will not come from that translation into bytecode. And most interestingly, this takes away one of the key requirements of any effort in this space, which is no programmers are necessary. Or vice versa, the other way to put this is all of us who can speak a language are now programmers. That's a little scary. This is why I said this is either a crazy idea or a totally worthless idea or a great idea. So it's that we all get to write program specifications in our native languages. So this, I think, is really, really interesting. It's exactly like having a smart trust executor, a smart agent, someone who is, who's been bred and has consumed all human knowledge available in digital form. Someone whose common sense we can appeal to. You can assume that they understand a fair deal. So make sure this transaction is fair. You could actually say that. And it would have to then think about what that means. Oh, now, then the income would have to be divided somewhat equally, right? That's what we all define. Oh, by the way, this is something that I learned in my days as a professor. The word fair has no definition. I couldn't define it for you. Think about it. People would come to me and say, oh, that's not fair. Well, I would say, people over the age of 18 typically don't, we stop using that word. The world is unfair. And then fair, by the way, does not have a definition. It's really hard to define in a mathematical formal sense. But now with this, we all understand the concept of fairness. You can now appeal to that is built into the LLM. And now we no longer have to specify minutiae. So in this chess game, we don't have to specify any of the rules of chess because it's already been learned by the LLM's wanderings over the many, many, many thousands of chess games on the internet. There are a couple of little issues that I'm sure people will bring up. One of them, of course, is determinism. The LLM has to be deterministic because, after all, these transactions are going to be executed in replicas that are in each and every one of the validators, and they all have to compute the same result. They all have to compute the same balances, the same side effects. So we need deterministic LLMs. Many of the ones that are currently available are not deterministic. So one could do two things. We could build a new deterministic LLM, and I'm very, very optimistic on how fast these things will evolve. Or we could use a standard random beacon. That is, we get our source of randomness from some standard location and then make use of a non-deterministic LLM whose non-deterministic inputs come from the random beacon. I mentioned that explorers are going to be a mess because these interactions could be in any language. But if you want, you could restrict this sequence in any way you like. Right? You could do something like this transaction starts a sequence that only accepts inputs in English, and then whatever else it does. And now the rest of all of the transactions now have to be in English, and now we can all understand them fairly easily. The big question, I'm sure, I hope, that is on your minds is this even a good idea? And I think you should be asking this, because I find myself asking this question all the time about this idea. It will make smart contract programming much more accessible. We all get to be programmers. So nobody should ever come to me and say, I have a good idea, but I don't have a Solidity programmer. You have a good idea, write it out. Write it out with enough detail that it can execute with an LLM. Users will have to have full clarity. We'll end up having full clarity about the intent of a smart contract. It's in English. You don't need to look at the semicolons, the brace, the nesting, and so forth to understand how it behaves. It's written out for you. Now, we will see how that behaves, of course. It might be so complicated and so full of fine print that it might be kind of crazy. But nevertheless, it's a language that we all speak. The only caveat, and that's the big caveat, is that specifying contracts in a human language is remarkably difficult. There will be many spectacular failures. Billions will be lost, and I say this with a smile on my face, even as I'm excited about this idea. I know that it will lead to catastrophic failures as well, and I hope that we will fight to come up with some standard sequence patterns that will avoid them. So when we were tossing around this idea, one of the things that came up was, you start a contract. This is a contract between me and you about lending, etc., and then you come in and say sequence, transaction 2 in the sequence. Now the contract behaves kind of like my grandmother, and now the word fair has an entirely different meaning ever after that point, right? So you've seen all of these ChatGPT hacks where people escape the environment. They ended up having ChatGPT do really funny things, and so all of those will apply in this context with value attached. So we will all have to learn if we go down this route, and I will tell you all about what we're about to do, but we will all have to figure out the very different ways of specifying things in a manner so tight as to leave no room for those kinds of behaviors. So I want to leave you with this wide blue yonder idea. I do believe that this LLM-based subnet is an experiment that we simply cannot afford to not perform. That is to say, it's so exciting, so interesting, at least to techies, that I'm really, really, really looking forward to exploring this. The upside is reaching the next 5 billion users or 7 billion users. It's not going to happen with incremental changes to Solidity. It's not going to happen with moon math that comes down the pipe. It's not going to happen with ZK this and that. It's going to happen by rethinking everything from the ground up, as we did with everything we did at Avalanche. We did it with the consensus layer, we did it with the bridges, we did it with everything else, and now we're bringing that same sensibility, that same approach to the specification of transactions themselves. The ability to avoid smart contract programming and audits and so on and so forth is going to be really interesting. And the ability to onboard billions of new users who use their native language to transact, their native language to execute things on a chain will be invaluable. So with that, all I have to say, I think, is that the future is taking shape on Avalanche, and this is a new project on which we've done very little, and whose development we plan to do out in the open, and I invite all of you to help me and the various different people who are interested in this idea to collaborate in building this future. Thank you very much.